This is the two-way ANOVA video on analysis strategy. Because the two-way ANOVA only utilizes two predictors, analysis strategy is particularly simple and only requires two steps. The first step is to determine whether an important interaction exists. If so, your task is to describe that interaction. If not, you should fit a main effects model and describe the impact of the two predictors separately. The statistical comparison is accomplished by a partial F-test, comparing a full model with main effects and interaction with a reduced model containing main effects only. This information can be directly extracted from R. When the interaction term contains multiple degrees of freedom, you should be careful to find the single p-value associated with the interaction variable, not the multiple p-values associated with the various terms that constitute that interaction. This is an example of the sort of qualitative interaction that, if statistically significant, would probably be biologically significant as well. Specifically, the interaction is that the biomarker has a strong impact on outcome for males, but no impact for females. This interaction would be even more noteworthy if the biomarker was associated with higher outcomes for males and lower outcomes for females. In the example, saying that the biomarker has a differential impact on outcome by gender requires a formal statistical test for interaction. It isn't sufficient to show that the impact of the biomarker is statistically significant for males but not for females. As illustrated in the slide, that's saying a different thing. This is a counterexample to illustrate the previous point. The confidence intervals overlap, strongly suggesting that a test for interaction won't be statistically significant. Nevertheless, statistical significance was observed in one of the subgroups, but not the other. If the interaction term isn't clinically important, then you should proceed to step 2 of the algorithm, namely, to refit a main effects model. The impact of each predictor after accounting for the other is assessed using a partial F-test. If one of the predictors isn't statistically significant, you might consider dropping it and fitting a one-way ANOVA model with a single predictor. Investigators don't always take this final step. For example, if the study was designed to assess the impact of two predictors, it's often the case that both predictors will be retained in the analysis regardless of statistical significance. A particularly nice thing about the main effects model is that the impact of each predictor can be reported separately, in exactly the same way that you'd report the results of a one-way ANOVA with a single predictor. Specifically, you report a point estimate, confidence interval, p-value, and an assessment of clinical significance. Although what you report is essentially identical, the interpretation is different from a one-way ANOVA. Now you're able to talk about the impact of factor A after having accounted for the impact of factor B. As for any model having a continuous outcome, you might also report an R-squared statistic for the model as a whole. This slide summarizes the tests that you want to perform. They're called partial tests. And this slide lists two caveats. First, it isn't a good idea to look at main effects in a model that contains interactions. Secondly, you should look at the p-values associated with partial rather than sequential tests. The next slide illustrates the difference. The sequential comparisons build the model one term at a time. The first comparison in the group, the one pertaining to factor A, takes place within the context of a model that doesn't contain factor B. This is the comparison that's particularly problematic. Unfortunately, R can sometimes default to performing sequential tests. Some analysts begin a two-way ANOVA with a test of whether the most detailed possible model, that is, the one with effects for factor A, factor B, and an interaction between the two, has any predictive capability at all. If this test is non-significant, they stop. Other analysts don't perform this initial assessment. For now, all I'll do is mention that analysts disagree about this question, defer further discussion until we consider algorithms for variable selection.